In this example of how you can leverage Autodesk ForceEffect powered by Autodesk Simulation for high iteration conceptual design, we're going to leverage it to design a truss bridge across an existing ravine. So we start by launching the application and creating a new diagram. Next, we're going to leverage a background picture that we took of the ravine to draw our diagram on. Now that we have the background image, we can zoom into the area of interest. And in this case, we did take some measurements on site, and we know that the distance across the ravine is actually 900 feet. One of the powerful things we can do with Autodesk ForceEffect is we can actually scale the diagram to exactly match the scale of the photo we took, thereby getting realistic and accurate calculations. So here we hit the scale diagram command, and we say, you know what, scale the entire diagram with this line being at 900 feet. So now all the calculations will scale accordingly. So now I can draw the individual segments for the bottom of the bridge. We'll set all these at 225 feet, and we'll start with a design that has 4 of them. And we can go from there. I think we missed one, so we can go back in and reset the distance on this one by just clicking on the dimensions, setting it to 225. And now we can go ahead and remove our, we'll go ahead and undo that. And we'll remove our reference line. And now that we have the bottom structure of the bridge, we don't really know exactly how we're going to design the bridge, and that's one of the powerful uses of this tool, is we can just start to iterate and come up with some concepts. So notice that we can get inferencing so that we can align points where they're of interest. And we'll start with a basic kind of a triangular shaped bridge here. And we don't know what the truss supports are going to need to be like, so we'll just start throwing in a structure here so that we can start the analysis. Maybe we'll have a center support as well. Now that we've got the basic structure in there, we're ready to start applying some loads. And in this case, we're going to analyze just a very simple scenario. We're not going to worry about wind shear or snow loading. We're just going to look at basic straight down point loads across the supports. And we're going to say, for this bridge, we know we need to take about 12,000 pounds across each support. Again, the forces have scaled off the screen, so we can simply pick the background, scale them to fit. We'll go ahead and add our next applied load. Applied loads at each of the points, and then we can go back and edit these values. Set this one to 12,000 pounds, and we'll set a matching force on this side at 12,000 pounds. And we believe we're going to have about 6,000 pounds of input force at the mounting points. Okay, now that we have our forces, we're ready to apply our supports and start analyzing the reactions in the bridge. Start with a pin support on the left side, followed by the sliding support on the right side. Notice we've got a statically determinate indication, which means our solution is automatically solving. You can see here we've already got the reactions across each of the supports. Now what's great about analyzing a truss structure with this system is I can just go in and start interrogating each and every one of these members individually. I can see that one's in compression with about 5,400 pounds of reaction across the supports. You can see this one's in tension. And it's giving us a really good feel for how the reactions are being supported. Well, one thing I noticed is in this scenario, we have no reaction across this member HD. And we have the same scenario on the other side of the bridge. That suggests we might be able to remove those redundant elements and still get the same design performance. So let's check that scenario and see if it's true. We're seeing 5,400 pounds of reaction across point J. So let's just go in and remove these members, which will put our system into a non-solvable state. Now we need to go in and add weldments here. We can turn these into single elements, and that should put us back into a solvable state. Now if we go back and start interrogating, we can see that we still have the 5,400 pound reaction force across J, suggesting that those members were redundant, they can be removed from the system, and we just reduced our cost in the design. Now I may also decide that I want to play around with the geometry of the system as well, and since the problem's already set up, I have full capability to go in and modify the design any way I see fit to improve its performance. Notice the ease and flexibility at which ForceEffect gives you the opportunity to iterate multiple concepts. Now that we've got the truss design that we like, we can go ahead and generate a report. And this report will give us the details across each of the individual members of the system and the equations for solving those systems. Assuming we like what we've got, we can now take and send by email the final report to our professional engineer for approval.